Hey everyone, welcome to Dependency Management with Composer, PHP reinvented. Thanks. I'm Neil Zatterman. I am one of the co-creators of Composer, and I also work in a number of other open source and free software. One of them is PHPBB, which I think a lot of you have probably heard about at some point as well. I work at Formatic, and Engineered is kind enough to sponsor some of my work on Composer these days, as we've been trying to come to a point where we can spend more time on actually supporting this open source project. They've started up out of that as we're trying to come up with some ways of financing the amount of time we end up spending on this project. Let me start by talking about package management, dependency management. What is that even? All of you have probably at least used a couple of these on the slide. This is just different mechanisms, different tools used for managing packages, managing software, managing libraries in different environments. You have like the standard Linux distro tools, but a lot of language environments come with some standard tool that's used to install packages on them. So I think nobody could think about Node.js without thinking about NPM, just to kind of go hand in hand, for example. And for a long time, PHP had a couple of not quite so fun tools to do similar things. I guess the oldest one of these, I've listed copy and paste there literally because that used to be for a very long time a way that people would actually install libraries into their project. Download the zip file, stick it in there somewhere. Or maybe download the zip file, extract some directory from it because you don't want that whole project that's not offering individual packages, but rather just some huge monolithic application. There was a time where Subversion was pretty popular. SVN externals was one of the things that was actually used quite widely in the PHP world. And there's always been Peer. I'm kind of curious, just to make sure I'm kind of covering everything. Who here has used Composer before? All right, that's pretty much everyone. OK. So the thing is, I wasn't quite sure what to prepare for, so I'm going to jump through some of the introductory stuff a little faster, I think, with everyone doing that already. Who here has used Peer? Who here has done something other with Peer than install PHP unit? All right, still a couple people, but a smaller amount of people. So I think one of the main issues with Peer at the time was just that it was a little complicated to use for anything other than those couple standard packages available. Because Peer kind of described lots of things at the same time, not just the installer that Composer is today, but also a particular library of components, and as well as the protocol itself. So how did Composer actually come about? And I mentioned earlier that I work on PHPBB. And we actually set out to build a new plugin system for the forum software. And this was around the same time that we decided to start working on porting PHPBB to Symfony or making more use of Symfony components. Symfony 2 is just released as the first preview alpha release. And we started talking to those people and kind of realized they had a lot of the same problems. And if you think about it, as I listed before, pretty much any software developer anywhere has this problem of having to install different software and trying to or rather trying to modularize their software and need some way to describe those dependencies between different packages. So rather than actually build this plugin system, we ended up creating Composer. Oops, that image didn't quite load. There we go. Reload helps. Composer consists of a number of different parts. So you've all probably used the CLI tool Composer, which is just the thing that you install things with. And the interesting part here is that this is really a very thin CLI client on top of a library. Because as I was pointing out earlier, we actually built this for PHPBB to be a plugin system. So most of this functionality can actually be used as a library without having to use the CLI tool. And more recently, we've started to see some pretty interesting projects making use of this. Certain plugin tools for applications, like some block tool that installs plugins. making use of this without having the user actually use the Composer CLI tool, but just making use of the library to install dependencies for a particular application. And one thing that we try to encourage with the CLI tool, and that we always like to talk quite a bit about, because I think this matters a lot more than what the tool itself does, is standards of interoperability between different PHP projects packages. Because sure, there's some tool to install all of these, but if they don't work well with each other, what's the point? So we try to enforce certain standards that help interoperability, and I'll get into a couple of these later on. There's packages, which I'm sure if all of you used Composer before, you've seen before as well. This is just the open, like it's open to anyone. Anyone can submit packages there. And the part that I want to point out here, because it'll get a bit more interesting, is that the entirety of packages is based on this idea of feeding directly off of VCS repositories. So there's no build process. There's no uploading packages to Packagist. There is no creating versions on Packagist. All of the information that you find on Packagist is automatically read from Composer configuration files on the respective repositories. There's Satis. I'm curious who of you have used Satis before? All right, this is hopefully a smaller group of people, because I'm going to explain how it actually works and how to use that. So Satis is your way to host your own repository of packages. So if you don't use just those open source packages available on Packagist, but you have maybe your own private packages on your own repository somewhere, or, that's kind of interesting, if you're trying to proxy other Composer repositories. So if you don't want to rely on packages being available all the time, if you don't want to rely on the downloads being available from GitHub, you can actually use Satis to download a partial copy of Packagist that you use yourself. And if you're trying to install your own projects using this, you are no longer required to rely on the availability of our open repository. And a little more interestingly, a little newer, is a Torrent proxy. I mentioned earlier that we're trying to come up with some way of financing our sustained involvement in Composer. And Torrent proxy is a tool similar to Satis, a little nice, more user-friendly in that it has a web user interface, which makes it a little easier to do what I just mentioned, proxying Packagist, proxying GitHub, storing temporary copies of the information on there, and publishing their own private packages. This is open source, however, not in the free sense that we usually like to think about. It is free for personal use. However, we do ask for commercial use to pay for licenses of the software simply to support the open source software. It does come with a full copy of the source code, which you can make modifications to. So that's simply like a new tool that we offer in addition to Satis, which is fully free and open source software, which makes a couple of these things just a little more user-friendly. So if you're interested in either of these, you might want to look at that as well if you have some commercial use for this. And another one I mentioned is Composer installers. I'm actually not sure, this list I haven't updated in a while, so it's probably gotten even longer. And I think even when I created this originally, it wasn't quite this long yet. Sorry, it was already longer than what's on there. This is a number of projects that are quite widely used that can all have their individual modules, plugins, that are installed with Composer, even though they don't follow all of the standards for interoperability that we recommend, using specialized installation tools that know about the individual paths and installation steps necessary for all of these tools. So even if you're using like any one of these and you'd like to automate some of the installation of plugins, modules for these, you can use Composer for that. All right, so that was just a quick overview. I imagine most of you heard about most of these before. You all said you used Composer before. I'll just jump through this real quickly. There's the installer that, I always like to point this out because it's a little curious. Composer isn't something that you usually just download a file of. It should, I hope this is like large enough for everyone to read. It was a little small. Basically, you download an installer script and pipe this into PHP. And the background behind this is that we ship Composer as a FAR file. And there's still a number of configuration flags that make FAR files difficult or impossible to execute. And when this does happen, it doesn't give you any error information. So we don't recommend that you just download the FAR file, but instead on our download page, we'll give you this little piece of code to run on your shell to install Composer. But all it does is really download this file and check for those configuration settings to make sure that you can actually run Composer properly. Right, you run Composer install. I think most of you would use Composer, so you've seen this before. Installs a bunch of packages. You end up with a vendor directory that contains all of these different folders. And this is the part that's different if you use any of the Composer installers. Then rather than sticking it in there, it'll stick them in the respective directory that the particular project needs. And this is what a Composer JSON looked like that defines the dependencies. And kind of interestingly, this has to be in the root directory of a project. This is a limitation that wasn't necessarily intended to stick around forever. This led to a little, I don't know, there's some interesting aspects like the Symfony framework that consists of a lot of components. The current standard way to have a single repository and including a number of packages is actually to create mirror repositories for each of them, because you're still limited to having this Composer JSON in the root directory of your repository. The upside of this is that it's a lot easier to understand most packages in that they always follow the same structure. So there's like an up and a downside to this. All right, so here it gets a little more interesting. So even if you used Composer before, I'm not sure that, I think I see misconceptions about this a lot. A lot of people aren't entirely sure what these different files do. Composer JSON, everybody's kind of touched at some point to define what dependencies their project has. And then you have this vendor directory that things end up in. But there's a step in between, which is the composer.log file. And it's a generated file that you don't touch yourself. It gets generated initially by running a Composer update or install command. And as soon as it exists, you can only update the log file using Composer update. While the Composer install command tries to install the contents of the log file. So there's these two key commands that Composer offers, update and install, and that's the relationship. Update goes from the JSON file to the log file and then runs an install. And install simply goes from the log file to the vendor directory. You can use various options to influence the process of how the log file is updated specifically, and I'll get into these a little later. There's also a couple of relatively unknown ones that are pretty useful for certain situations. But the key part is really understanding this life cycle of running install whenever you're just trying to get whatever dependencies the project has, and running update if you're trying to actually change the versions of any of the dependencies. And the actual versions are documented in the log file, while the JSON file, well, it simply defines a range of versions that the piece of software should be compatible with. The log file only applies to the project that you're working on. So if you're installing a library, the only thing that matters is the version constraints defined in the JSON file. Based on these, dependencies are resolved, and your own project receives a log file that defines the precise versions of all of your dependencies. However, the log file itself is only applied to the individual project that you're working on. So what's the point of all of this? Well, first of all, please always commit this file into your VCS repository. I do realize that there's a bit of discussion over this. It's something that's been discussed in a lot of communities, because this isn't our idea either. This came from Bunder in the Ruby world. And there's really no downside to committing it. The result is, let's say you're working on a project with a team. All of you, if you run Composer install, get the exact same version of all dependencies. You don't just get any version that matches the constraint, but you get the exact same version. So if somebody published a small release for one of your dependencies, this could result in some difference in behavior that you need to then fix in your code. But some coworker of yours might be trying to just get the project running, and then for some reason they get this new version because they're installing it later than the person who checked in the log file, who checked in composer.json because they didn't check in a log file. And consequently, they end up having problems with their code simply because they have a different version of the same code. So this process makes it very explicit when you want to switch to a different version. You have to explicitly run composer update, and only one member of your team does this, and then all other members of your team have those exact versions that all of you are working with, that all of you know that the tests run with. The next step is doing this across servers. If you're using Composer as part of your deployment process, then you want to make sure that all of your servers run the exact same versions of all dependencies. You don't want them to just run any of the versions that you think your software should be compatible with. You want to be certain that it runs the exact same versions. So again, the log file comes in to make sure that you install those specific versions rather than anything that matches constraints. And again, if you're supplying an application to users, all of those will have the same versions if they use Composer themselves to install dependencies. You have a question? Please, Scott.
So this applies, would it also apply to libraries?
Yes, it does. So this is the point that I was bringing up earlier. People always get confused over this because I did point out that the log file is only useful to the project that you're working on. So if you're working on or if somebody publishes a library, why would they include the log file in the library? Because it doesn't apply to the user of the library. But the user of the library is number 3 here. Number 1 and number 2 are still both interesting for libraries because there's a group of people working on a library and they all need to run tests. Now you want to be able to verify that a particular bug is based on a difference in versions. So if someone runs into, doesn't use a log file, another user reports a bug against the library, you don't know whether this is the cause of a different version of a dependency being installed or a bug in your library. So instead, make sure that they all use the log file. And then if you want to run tests against a different version, use Composer update to test that different version. And then part of the bug report is we made the following change to the log file. And you can verify that the bug is actually part of this particular dependency change. So yes, even if you're working on a library, you should be committing your log file for other people working on the same library. And the server part really applies only insofar as that it's interesting if you're using continuous integration. You kind of want the continuous integration service to test your software with reliable versions that you know which they are. And you may, as part of your testing infrastructure, actually install different versions of your dependencies. I'll get to how to do that in a bit as well. But you do want to be deterministic with this, and you don't want to have random versions installed that you can't later verify actually caused or didn't cause issues. All right, next part that Composer does is when it installs all of those libraries into the vendor directory. And then part of your Composer.json is an autoloading section, which makes use of PHP's autoloading. And there's a new thing here, which is PSR4, that replaces the old PSR0 autoloading standard. PSR0 is this mapping of class names, of namespaces and class names to directories and file names. And in PSR4, this has become a little simpler because you can skip common prefixes within projects. Because what ended up happening is that you typically use a namespace of some company name slash the particular project, backslash the particular project, backslash this one component, backslash this subdirectory, backslash the actual class. So you end up with huge paths for everything, even though most of those directories contain exactly one subdirectory. So the idea behind PSR4 is to simplify these directory structures. And you can simply specify the prefix namespace in your Composer.json, and then all of the classes in there are assumed to have this namespace as a prefix for them. Yeah, the autoloader ends up in vendor autoload PHP. And again, since most of you have used Composer, you simply require this one file, and you can start using all the classes and all your dependencies. And there's a command to regenerate this autoloader, especially if you're using a class map for some project that doesn't follow PSR0 or PSR4, which means that you generate an explicit list of all the classes in the files or directories that you've listed. then you will need this command regularly to update this list if you add any new files. And namely, there's two options, no-def and optimize, that you should be running if you dump an autoloader for a production system. Optimize generates such a class map for PSR0 and PSR4 autoloaded directories as well, which makes the lookup fast as it doesn't have to actually search for the files. And no-dev excludes all development requirements from the autoloader. So even if you do install development requirements, this way you make sure that they are not being autoloaded and reducing the autoloader in size. All right, so one of the standards that I said, and this is something that is, I think is very important to me that a lot more developers take to heart, and that's why I want to focus on this for a bit, is semantic versioning. Semantic versioning is this concept of having version numbers consisting of 3 digits, major release, minor release, and patch release, so something like 1.2.3, in which the patch release is exclusively for bug fixes. The minor release should be incremented whenever you include new features. And every breaking API change should increase the major release. If authors of libraries strictly follow the standard, it makes it a lot easier for users of those libraries to require the correct versions and to build, or rather to define future-proof version constraints. So a couple easy, just a walkthrough example of how this works. Development version could be 0.10. You fix some bug in it, it's 0.11. You make some breaking changes. This is an exception because we're still in development mode 0. So the breaking changes simply lead to 0.20. And then you decide to make a stable release. So the first one is 1.00. You make some bug fixes, 1.01. Some more fixes, 1.02. You include some new features, 1.1.0. And then you make any breaking changes, and it's 2.00. All right, so that's how semantic versioning works. And now I want to get a bit into the details of how to precisely pick versions in your Composer JSON. There's a few pretty obvious ones. These exact match constraints, where you simply specify the particular version that you're looking for, like any of these. You can use ranges. Simply use an asterisk in a place. So this would include simply 1.0 point any version, 2 point anything. All right, so next thing, you do have comparison operators in there, but please don't use just one of them in a version constraint. So if you're doing something like greater than or equal to 1.0, you're basically saying that your library is going to be compatible with any future version of this particular package. And that's a very unlikely to be true statement. I don't think I've ever heard of software that was compatible with any future version of another piece of software. So please feel free to use these operators, but combine them with others. Yeah, and there's and or operators for version constraints. You can combine 2 of these constraints, greater than or equal to, with less than, using an and operator. And you can also use an or operator if for some reason, there's one particular release that was bad that your software is not compatible with. You could use 2 ranges and combine them with this. All right, so the more interesting operators, and these are a little more tricky to understand, are called next significant release operators. There's the tilde operator, which is the first one of these 2. And if you write tilde 1.2, then this means at least version 1.2, which expands to version 1.2.0, and then up to version 2.00. So if you're trying to describe a version constraint related to the semantic versions earlier on, so let's say I want to be compatible with all versions up until the next one breaking API, then you can use one of these operators to say that you'll be compatible with any new features, but you won't be compatible with any breaking changes. And it gets a little more specific. If you add 1.2.3, then this only goes up to 1.3.0. I know this isn't precisely what the semantic versioning defines anymore, because this says I'm compatible with all fixes, but I'm not compatible with a new feature, which is unlikely to be an issue. So as of I think about 2 months ago. There's a new operator that more strictly adheres to the concept of semantic versioning. So for 1.2, it would work the same way, but for 1.2.3, it still only goes up to version 2. So the caret operator is kind of what you want to rely on if you know that your libraries that you're using are following semantic versioning, because you can specifically state that you will be compatible with any future releases until they make API breaking changes. So if you're building a library yourself, and that's when it's important what the constraints are, you should be using one of these two operators. Because if you're building an application that you're delivering to users, then your log file is important to make sure that users get the right versions. If you're building a library so that other users depend on your constraints to match further dependencies they have, then please use these operators so that they don't end up with versions that don't actually work with each other. All right. The next part that influences which versions of which libraries you end up with is stabilities. So we have versions, like the numbering, and there's composer stabilities that are development. It's kind of a flag for each release. It's a development mode release, it's an alpha release, a beta release, an RC release, or a stable release. And these are automatically read. I think I brought this up earlier on, like packages as well as status, they all read this information from these respective VCS repositories. So the way that you make a release is by tagging it, or even branches are available as versions in Composer. So if you tag it, a 2.0.2 would automatically be detected as a stable version, while if there's beta in there as a suffix, even with a number after it, it'll be detected as a beta release. Similar thing happens with branches. We try to do this as automatically and as intuitively as possible. If you have a branch called 2.0, then the version we detect this as is 2.x dev. So it's a development release like any other branch. Master is usually available as dev-master. And the same applies to all other branches. So if you create any feature branch on your repository, these actually become available through installation with Composer. So this is pretty useful in development if you're trying to try out a new feature that you're working on in a library in your application. Then you can actually require this particular branch that you're working on rather than having to tag a specific version and rely on this. Now, on the requiring side, in your Composer.json, when you're trying to use any of these, by default, Composer comes with a minimum stability of stable. That means it will simply discard all versions that are not stable. Now, if you're trying to use any of these other stabilities, you can either simply increase your minimum stability, so let's say to beta in this example, which means it will no longer discard beta or RC releases, or you can set this to dev and it will simply use all releases available. And this will apply to, and all of your constraints will then apply to these releases. Right? So these are two separate concepts. First, it discards particular versions, releases, and then it applies the constraints on these. However, you can also explicitly state the stability that you want for one particular package. So if you're saying, I would like to install this particular package in version 1.3 or above, but I do want to include alpha releases, then you can use this add alpha flag in your Composer.json. Or add beta as in the one below. And this is simply a suffix to add to the version constraint that you're defining in your Composer.json. Okay, so this is the way that you define all of your different dependencies. You make sure that all of the version constraints match. And then you use Composer update to update your log file. And here's a couple of command line options that are interesting or good to know. First one is probably still pretty common. If you're doing anything in production, use no dev to make sure that you're not installing any development requirements. Now the default is that you're installing development environments and that it prefers to install them from source, which means it will try, if possible, to git clone, to svn checkout, to give you a VCS repository for your dependencies so that you can actually go into this vendor directory, make changes to the files in there, and commit them. So it's easier for you in development to work on a number of projects without having to check each of them out individually. This makes it typically a little slower. So in production, it is easier to use prefer dist, which will try to download zip files if available. Prefer stable is an option that influences which versions get selected. Because like earlier, let's say we use a minimum stability of beta, and there's a better version for something available that's newer than a stable version that would also match our constraint, then this better version would be installed. If, however, we only want the better release to be used if there is no stable version available, then we need to use prefer stable, which will use a stable version if available, but still allow for the better version to be installed if that is the minimum stability. The last two are pretty new options, added only this in the last month. Prefer lowest will try to install the lowest available version matching your version constraints. And this is a really useful thing for testing, because you're trying to ensure that your version constraints actually are still correct, that your software does still work with all of these old versions that you're listing in your version constraints. Then you should be using prefer lowest as part of your testing to ensure that your tests still run with all of these old versions. And the last one, ignore platform requirements, allows you to install a package even if the version constraints for PHP extensions, PHP itself, don't match, which comes in handy if you have a project that runs on a particular setup that you maybe have a vagrant box for, but you just quickly want to run this one particular test that has nothing to do with all of these extensions on your local machine where you don't have the right versions of those extensions. So you can still install all of the dependencies without it failing for missing extensions or wrong versions of extensions. All right, so as I promised earlier, I want to show you how to use status, and it's really straightforward. You simply use composer's build and create project command, or you check out the Git repository directly. You end up with a copy of status into which you put a file you can name however you want. The typical things to call is status.json or config.json. And this contains a list of repositories, similar to what you can do in composer.json to define your own VCRS repositories to load packages from. Your status configuration file contains a list of repositories that you would like to load packages from. And the default behavior is actually require all if explicitly written here, which means that all the packages you can find in any of these repositories will be published on your status repository. The alternative down here is that you explicitly list certain versions that you are interested in publishing on your repository using require, similar to composer.json. So in this case, package 2 would have all of their versions published, but package 3 would only publish version 2.0.0. Further, in this configuration, you can use the archive command. So by default, status looks at these repositories, generates the metadata so that your composer install can make use of this metadata. But the download will still go directly to the VCS repositories that you listed. Now, if you want to actually build tar files for these versions and have them downloaded over HTTP rather than always having to clone that Git repository, you can use the archive command so that status will automatically also build all of the different packages for the versions that you need. The prefix URL is the URL under which those packages will later be available. So status will dump these into a local directory, and then you need to make sure that this is available under this URL so that users of the repository can actually reach these packages. And the skip dev option, the last one there, simply allows you to skip over branches when building packages so that branches are always installed from the repository. And then building it is simply a call to the bin status script that's included in status with the directory that you're trying to build into, which is web in this case, and then you make sure that this is available over your web server. You can also serve this over SSH. You can really through anything that you like. Just make sure that it's somehow reachable. And then on the other side, in your composer.json, you include a custom repository of the type composer. A composer repository is really just a JSON file listing all of these packages, for example, like status generated at a particular URL. So let's say p.example.org. Or if you want to make this available system-wide to all of your packages or projects that you work on, you can actually use Composer's config file, which is in, I think it's a little too small, in your home directory .composer/config.json, or on Windows in this other part that you can look up on the slides later. It's a little long. And you can just list the repository that you like to use in there, and then all of your projects on your system will load dependencies from this repository. So it's pretty straightforward, let's say, in a company that you're working at, to set up a repository like this for everyone to use without a lot of hassle, without having to manually specify all these repositories. All right, so there's another part to the talk to the title of my talk, was PHP reinvented. Like so far this was just lots of Composer stuff. How does all of this work? And I think there was a couple talks today already, so I try to I shortened this part a little bit, that covered both all the new developments and like how PHP is being written, how these projects are laid out, what kind of new things are happening in the language. But I do want to briefly touch on this. I mean, the first thing we can definitely say, this is like PHP dependency management reinvented, but obviously Composer is a new tool. And I think the most important point of what Composer has changed and how people approach dependencies in PHP projects is that we no longer have a tool that you use to make state changes. So let's say with pair, you install a particular package. Even if you do this manually, download the some zip file extracted, and then you have it there. You had processes that changed the state of your project. But now instead, you have the Composer JSON file in which you define the overall system state that you're trying to reach. And the Composer JSON and how you manipulate it has nothing to do with the current state of the system. It doesn't matter what's currently in your vendor directory. You're simply defining a state that you would like all of your dependencies to be in. And then you have a tool that ensures that the state actually matches this description. So the overall process, how this works, has changed. And if this sounds a little familiar to you, this is the same thing that tools like Puppet, Chef, Ansible, Salt have been doing for server configuration, server management, server configuration management. It's a process that's become a lot more commonly used because it's easier to reproduce, more predictable. And I think this has helped PHP to make use of this a lot more, because it does make the whole concept more approachable, more easy to use. And you can see this if you look at some of the statistics. So this is the statistics we publish on Packagist. You don't have to read the numbers up there. It's just you see the graph and how it expands. We have over 50,000 PHP packages available on Packagist today. So if you're looking for something, it's probably on there already. If you're trying to build something new, maybe take a look, because it's probably on there already. There's over 200,000 versions of these packages. We have reached a point of over 50 million installations per month of individual packages. So the PHP world has been taken by storm by this concept of being able to install their dependencies in such a predictable and easy way. All right, so let's get back to PHP reinvented. And I think there's a couple goals that people had in PHP projects for a long time. And this is making APIs simple, easily approachable, improving code quality, and having a large amount of modularity, reusability of individual components of the code. And some of the programming, software engineering methods of achieving these are better separation of concerns. Dependency injection is something that's become really popular in the PHP world to make it possible to decouple individual components. Things like events make it possible to interact between components without strongly coupling them. And designing software with testability in mind leads to a very similar decoupling component creation of components. And we have these software engineering processes or methods on one side, and we have Composer on the other side as a tool that allows you to now actually package up these individual components so that you no longer have to do this as part of one massive code base, but you can actually do it as individual packages. And the result of this is a series of new frameworks. Symfony 2 was at the very beginning of this process. Things like Laravel, Silex. Something like Silex wasn't previously easily possible with PHP. It simply makes use of a number of these components of one of the existing frameworks to build a new framework. Yeah, so it's really easy now to just create a new framework based on a small part of another one, because you'd easily take all of those individual parts, when previously it would have been a hard job to even separate these things. So the combination of all of these engineering changes, of all the different methodology that people use to program PHP to build more maintainable, more component-based software, goes hand in hand with the possibility of actually using these as individual packages. We have a lot more single-purpose libraries. Right? No longer all just big applications that do everything, but we have a lot of small libraries that do particular specific things, like a static guzzle, like an HTTP client monologuing library. And that helps you in creating new applications, making use of these individual tools for specific things that you're trying to do. And overall, all of this has led to I'd say, a faster innovation cycle. And this is something you notice in PHP overall. I do think that all of these changes are interlinked. They led to a faster development of the language. There's a lot of factors into that, but I think that the increase in speed of new projects, new ideas, and how fast you can build them based on existing code has also led to changes to the overall environment in which PHP is written, to the language itself even. So this is kind of what I'd like you to do from now on when you're trying to work on a new project. The first thing is look around. What's out there already? Isn't there maybe something that already solves part of my problem? And then try to not address all of these problems at the same time, but write some of these single-purpose libraries. Solve one particular problem that you'd like to work on, and publish this one particular small single-purpose library afterwards. And then others can reuse the work that you've put into this, just as you reuse their work. And through this process, we will further increase this innovation time. We will reinvigorate PHP. There's a couple links if you want to find out more. Getcomposer.org is the Composer documentation. Packages.org I mentioned earlier. You find all of the code for Composer projects on GitHub. There's some Google groups for discussion for users or development. And there's also 2 RSC channels that you can find help on or discuss things surrounding Composer. Thank you, everyone. All right, I think we have roughly 5 minutes for Q&A. And you can also find me on Twitter and at Naderman if you want to ask more questions afterwards. I think there's one just here. Do we have mics for them, or should I repeat the? OK.
So Rove has the security advisories composer package, which has no code, but it just has a lot of version conflicts.
Right.
So I was wondering, is
OK.
it a clever thing, or should they not be doing that?
All right. So he's saying there's Rove has a package that doesn't actually contain any code, but simply conflicts with a lot of versions. And the purpose of this is to conflict with insecure versions of various software. So if you make sure that you install this package, you'll have a conflict with any version of a package that has a security issue. I actually wasn't aware of this, but it seems like a very straightforward way of doing this if the individual package maintainers who use that library don't update their dependencies fast enough. You can obviously do this yourself, as in like blacklist versions you don't want to have installed, but I think that's probably a pretty good approach. Yeah. I think it's the Rove, as ROAVE slash.
It's in their GitHub somewhere.
OK, that's the organization. Just look at ROAVE. It's like security something or other.
We'll tweet it with the hashtag.
All right. There's a question back there. All right, check it. OK, so the question is there a way to find out who is using your library through packages API? So use in the sense of who's using as in installing, obviously not, because we don't want people to find out who you are. However, If you yourself, well, there's two aspects to this. Composer itself actually comes with a command now that can let you know the dependencies of a package, or rather, and the inverse dependencies. So you can check what depends on this particular package, which makes use of packages API to give you this information. There's also a website called versionI.com, which has a lot of information about packages that simply uses packages and graphically displays this, where you can see which other open source packages depend on this package that you're looking at. I do think there's like 2 or 3 other projects that try to graph some of the information on packages. Unfortunately, I don't know the names off the top of my head, but you can certainly find some of these. But yeah, there's a couple ways to do that. All right, for the questions, all the way in the back. All right, so his point was, as I said, packages is growing and growing, but he said like his projects and his dependencies are too. So he ends up with a composer.json file that has more and more packages, and this becomes a little difficult to maintain as well. And yes, you actually suggested the answer. You can create meta packages. So a composer.json, if you're publishing a package, has a type that defaults to library. And there's actually another type called meta. That means that you don't have to, it doesn't contain any source code. It's simply a description of a package. And then this package can have a requirement on a list of packages that somehow logically belong together. So I don't know, maybe I'd have my typical web app package that includes like the framework I want to use, like the template engine I'm using with that, and a couple other things. And then in my projects, I simply require this meta package, which then has requirements to all the individual packages that I need. And through that, I can actually consolidate groups of packages or dependencies into individual composer packages. All right, any further questions? This is one with the red t-shirt. Uh-huh. Okay. Yeah. Yeah. Right. Okay. So yeah. There's okay. So he's bringing up two issues that he sees with Composer, and I think this is like a typical perspective of, I don't know. I imagine, do you maybe work on one of these distributions package managers, or are you like maintaining? Okay. So the first one was, sorry, no, I forgot about the first one. I'm thinking about the second one too much. Signing. All right. So Composer doesn't have any signing currently. Yes, it doesn't, and yes, we do actually intend to change that. However, all of the traffic runs through SSL. So you are limited in what can happen to attacks on typically two, like basically if packages does get hacked, then you're vulnerable to that because you don't have signing. And if GitHub, because most of this relies on GitHub, gets hacked, you have these issues. If GitHub does get hacked, then there's a lot of issues, I think. So that's one of these that we're kind of ignoring for the moment. You're absolutely right that packages is kind of like a single point of failure from a security perspective. And we do want to include signing at some point. This makes things very difficult for us because the upside we currently have of packages is that we can directly let people download stuff from GitHub. And they offer, for example, the zip archives for all their tags, which aren't signed, even if you sign the git commit that you tagged, and that then gets built into a package. So for us to be able to offer signing of packages, we actually have to build all packages for all of these open source projects on packages to actually have them uploaded. And we haven't quite figured out how to do that in a somewhat sane and just as easy to use way yet. And the second part, is actually somewhat related to this, is that Composer handles dependencies per application. And that is the very purpose of Composer, is we don't want to do system dependencies with this. The purpose of Composer is to build a application. Like the resulting product is something that I would install through a distributions package manager. But this is purely for developers, and it is not designed to install just one instance of a particular piece of code. The very idea of Composer is to manage dependencies of one project within that directory, have it self-contained. And so yes, I understand this is not what you're trying to do, but that is a very intentional decision to do that this way. All right, I think there was one more question down here.
Which kind of software inspired you mostly while building Composer?
All right. So the question was which other software inspired us mostly while building Composer, and this is actually a number. There isn't one particular one. It all started with me starting to work on the dependency solver itself, which is based on the set solver in libzipper, which gets used to install RPMs on OpenSUSE these days. So that's how we resolve all of these version constraints and how we figure out which versions of which dependencies to install. Then a lot of the configuration files, like the Composer JSON and how all of this looks, is inspired by NPM's configuration files from the Node.js world. The log files and idea we have from Bundler in the Ruby world. So Bundler is a tool on top of Ruby Gems, which turns Gems, which is another one of these tools where you install a package where you have processes to make changes, into one of these where you describe a state. So with Bundler, you describe the state, and Gem is being used to actually make those changes. So I think maybe those three, but there's definitely influence from others as well. Welcome. I think we're done with time. If you do have some more questions, come see me here before I leave.